Thank you, thank you, thank you. So welcome to DevOps Malmö, Skåne for this next event. Today we're gonna let Lauri talk about service levels and error budgets and why you should care, basically. We just a little bit about today. We're gonna have a meet and greet. We did that. Now we have the presentation soon with Lauri. We're gonna have pizza and drinks, and afterwards there's a Q&A, continued discussion during the pizza and drinks. And only the presentation and the couple of questions will be live streamed. So we are a meetup group that has existed since 2018. Lots of meetups, there are lots of members, and we are the three persons that run this show, right? And none of this would have been possible without Foo Café. And you can get in touch with us in multiple places. We're trying to get Discord up and running, so if you can try to find us, that would be awesome. If you want to post something, that would be even more awesome. And the next time is going to be in October, and it's going to be about platform engineering. Maybe why we hate it, right? This is going to get you to Discord. I can show you that later. Before we get to Lauri, we're going to thank our sponsors for today. That's Capiche. And Anders is going to come and talk a little bit about what Capiche is.
Thank you very much. I recognize most of you from other events, but for you who doesn't know what Capiche is, we're a software company. We thought we were, at least. We started developing a graph database for analyzing scientific data, and we found our niche in the pharma and biotech area because they have lots of data with hidden and formal relations. But then we also realized that we are a consultancy company because we have to clean up the data often before it's usable. So for the time being, we are not looking for any developers, but please follow us on LinkedIn, because when we can offer jobs as developers, it's super cool technology and you actually code with a purpose. Over and out.
And now Lauri.
Thank you, thank you. Let's move on to the other set of slides. Great, I have a presenter view here. Cool. There are quite a few people who weren't forced to come here, unlike a couple of them, so that's nice. I didn't know how many people there would be, so I'm definitely surprised. So, nice to meet you all. I'm Lauri, and I come from Finland. I actually flew here this morning just to work with my colleagues here and also to have this presentation with you. The company I work for is called Verifa, and we do DevOps and cloud consulting, also other things. And I'm mainly in the cloud domain. And in addition to doing these kinds of things, I also have a few hobbies, and I think at least my colleagues have heard quite a lot about them. But in addition to doing nerdy stuff, I do a bit more nerdy stuff, and sometimes even sport. So now you know me, and hopefully I get to know you. Let's move on to the actual bread and butter of this evening. And I titled this Service Levels, Error Budgets, and Why Your Dev Team Should Care. And the last part is the important one to me because there's lots of talks and also texts about service levels and error budgets, but like all of them kind of exist as their own thing. So even though this was marked intermediate, it kind of requires you to know something about it, but if you don't know what service levels are, I'm going to tell you what they are, and hopefully you get something out of it then. And the other topics we're going to cover is like, well, now we know what the service level are. So what are we going to use them for? How do we make them happen? And then why I, as a developer, would care about service levels. And then comes the error budgets, which is the kind of the application of this whole thingamajig. And as a motivation for this is that I've seen a lot of people talk about service levels. Not too many of them, when inquired a little bit more, seem to really know how they're going to be used, what is the application of them. And then all the texts are mostly on the operations side. So they start like, yeah, these are service levels. They are used to bring the operations and the development together. So let's talk about the operations, and developers can mind their own business. And that bothers me. And also, like, it's not that hard of a concept, in my opinion. But I've also, like, I talked with a fellow DevOps engineer in DevOps Finland, and he said that like he's seen them once or twice in the wild. And in my opinion, like, that begs a question, like, why? Is there a kind of an inherent misunderstanding how service levels work and how they should be implemented in software projects and software organizations? So, first interactive segment of this evening is that I'd like to know how many of you consider themselves customer service experts. None. All right. How many have you ever written code? How many have you had your code used by more than one people? Congratulations. You should be customer service experts, because these things don't exist as their own. We're writing software for something and for someone. And if you're writing software not thinking about the end user, who's going to use it and why they're going to use it, you're going to have bad time. And when it comes to service level, often I see that it's talked about like from the stability point of view. We're going to, this service is available almost always, but 30 seconds a month it might be unavailable, and if that happens, you are going to have some sort of compensation. But when looking at the trends nowadays, building software is like the beginning of the software life cycle, and most of the costs accrue during the maintenance and upkeep. And software is never really done. Like nowadays, we're doing things incrementally. We try to add things when the market so decides. When customers say, "Hey, this would be nice to have," then we're going to add this to the backlog and probably work on it at some point. So software, in a sense, is never done. And after like doing your first release, you're going to work on a software that is live. So that's when kind of stability matters for you as a developer. And this was a nice white paper from Siemens from last year. Like they said that this was on a typical heavy industry plant which had unplanned outages, and like in a typical large plant, it would like a unplanned outage would cost like $129 million per year, and they also estimate that this trend is going to grow. That even more companies are using the custom-made software, and they have to maintain it, and the outages could be even more more impactful. So, but a classic thing when it comes to software delivery, if you think about we have developers and we have operations. Nowadays in companies might be that these are the same people. So this could be an internal monologue as well. But the classic contradictory thing is that the developers want to make changes and they want to add features, and the operations side wants to keep the system stable. And here's the problem, like if you're going to do a change, that's going to risk the stability, and from ops side you'd rather not. But there's also, like from a business perspective, if you're going to do minimal amount of changes, you're going to lag behind your competitors, your software is not going to evolve and so on. You do too many changes, your software is going to be unusable because you're going to introduce a lot of bugs there. So that's where the service level idea kind of comes in, that we can align these goals based on that and strike a balance between, like, this is how many changes we are going to do to keep the system stable and so on. We're going to get to that later. So in addition to being that what the service levels are, they communicate the system health internally. So what we want to have, the service level is not just like a stability thing. It corresponds, like, this is how our users perceive our system. This is like, if our service level is adequate, users are going to be fine with the system. It also allows us to have an internal view to the system. And then going to the what the service levels are, there are these acronyms you might have seen before. So SLA stands for service level agreements, SLO, service level objectives, and then we have SLIs, so service level indicators. And we're going to go through these, what they are, what they mean, like from the bottom up, so starting with the SLIs, ending with the SLOs, SLAs. And the idea is that on the bottom we have SLIs that provide the data we measure, based on which we set up objectives, and maybe based on those we set up agreements. So, who has ever touched a monitoring system? Good, quite a few. What are typical things you have monitored? Just shout something random.
Responsiveness to calls or something like that.
Responsiveness.
Yeah. Like if it's up.
If it's up, that's like a health check.
Yeah.
Yeah. What else?
Nightclub.
What was that?
Nightclub.
Okay. There was. Yeah. So all of these are metrics we usually monitor, sometimes monitor, but only a few of them kind of cut as being a service level indicator, because a service level indicator has to be something that is relevant to our users and is relevant to how they interact with the system. So the second part, second interactive part of the evening is now we're going to have a short pop quiz, and everyone tell me if the following are good service level indicators. So, queries per second, good or bad? 95th percentile latency. Number of ports in a Kubernetes cluster. HTTP error codes in a minute. Kinda, yeah, you got it right. Queries per second is not a good one because it doesn't really scale. Sometimes you might have quite a few, only a couple of queries, and then you have some high peak and it's a lot, and then you get, that's what you're going to tell about it. Like nowadays, lots of queries, and nowadays quite a few only. So we can't really make any kind of a judgment out of it. Thanks. 95th percentile latency kind of tells us how the system is behaving currently and so on. It wouldn't be like a anti-SLI would be like, well, what's the latency for this set of queries during, like, now it wouldn't have enough data to it. Number of ports in a Kubernetes cluster might interest us as if we maintain Kubernetes, but like from a user's perspective, it's not very relevant. They care if the system works, not how many ports it runs on. And HTTP error codes in a minute, kind of, if it was a percentile. Like, we don't do much with the, like, yeah, sometimes there's 100, sometimes there's 1, but like, if you're going to have 1,000 requests and 100 error code, that would be a 10%. But if you have one request and it fails, then it would be 100, and you would like raise your arm. There's a question there.
To add to that, if you were to implement that, you have sort of sliding window.
Exactly.
It's actually the usually 10th of a percent and now 5%. That's more interesting.
Yeah, that's true. So going a bit ahead there should be time bound as well. So like instead of tallying the whole HTTP requests we get throughout the life cycle of a system, it doesn't really bode well in quite a few senses. Then we have service level objectives. So they are built upon these this data and these indicators we choose. So these should be internal targets you as a developer team set for yourself. Like, we try to achieve that. For example, when it comes to, let's say we have less than 1% of wrong, like HTTP 400 something in a minute of all of our requests. Some companies choose to publish these, but they are quite confident in their own ability. But usually, it's kind of to manage the end user expectations rather than telling them that this is going to work. For example, some APIs might tell you that this is the average response time, so you can expect that when you're going to use that API. And this service level objective should, in general, correlate with the user expectations. So, kind of that the user can manage, for example, this every 1,000, 1 in 1,000 queries could be faulty, and that's fine, most of us. But one thing that this is one takeaway I'd like to have everyone take home from this, like SLOs should warrant actions when they are broken. Like if you're going to, kind of same with the alerting, usually SLOs come with an alert, probably before that as well. So like if you're going to break your SLO, you know you are doing something wrong and you have to remedy that somehow. And then the service level agreements. These are a contractual thing. Usually, usually you have the legal department and the marketing department can tell. Like you see this on cloud platforms that this service provides 99.99999 the nines, the availability or some stability issue, and this is something you promise to your customers, and it usually has some obligation when that is being broken. And one good practice is to set the SLAs higher, or the otherwise the SLOs lower than the SLAs. So before you're going to break your customer promise, you will have a head warning for that. It doesn't mean that you should treat SLOs like just, all right, we broke that, but we are not even close to breaking SLAs. We can ignore that. But not all services need SLAs. For example, Google Search is a good example for that. If you would tell all of you users that, yeah, Google is going to return you the most relevant one, and someone, this wasn't relevant to me, you have broken the promise, it would be a mayhem. You have to be aware that what is the customer promise that your system delivers. So, now we know what the 3 acronyms are, and we can start thinking about, like, okay, we're going to implement this. What are we going to measure? And we saw in the SLI slide that these should be scalable things. This should be relevant to our users, and they should be somewhat like repeatable in a sense, and they should be time bound. But of course, depending on the system, there is no silver bullet for setting up the things to measure, setting up the SLIs. For example, like we would have a, well, I worked in a startup and they had a reporting system, and for a web application we made, we had an SLO for response times. It had to be like 95th percentile had to be under, I don't know, what was it, 100 milliseconds or something like that. But the reporting system took 20 minutes to run, usually. So you click that, and the report would be generated in 20 minutes. And obviously, we couldn't set this kind of a like a time limit to that. And why would we? Because the users who use the reporting system didn't care that they, they only cared about they would get the report the same day they requested that, and that the report was correct. So it could have taken even more time, but that was not the relevant thing to measure. Like we did measure how long it took, but it wasn't like in our cards to really care about as long as it ran correctly. Then we have things like correctness, which is a hard one to measure. And some people asked me, like how are you going to measure correctness? Like, a good example would be some kind of a journey planner. You want to have a good enough result from there that doesn't like route you to somewhere you don't want to be in. It doesn't have to be exactly the most correct one, as long as it's reasonably good. And that's what we care about. And that is something that we can measure, that we say that during these distances, we should be able to calculate a route that takes, let's say for a 100-kilometer radius, you should be able to take that under 1 hour and 20 minutes. Availability, which is often seen in these SLAs, it's not a really good metric per se. For some, for example, if we run our stuff on managed databases, it could be a proper one. But let's say we have a server, we run a application on it, and it's available 23 hours a day. I mean, yeah, that's good, but it is down 1 hour a day, but it's still within our SLOs. But if that 1 hour period is when it's supposed to be used, then our SLI or an objectives wouldn't really correspond to the customer and the user needs. So, and this one was kind of asked from me to add here, like, yeah, we have talked about, this is still kind of feels that it's in the operations domain. And well, we are measuring latencies, and so it doesn't really have to do with my code, does it? We are measuring availability. Servers are operations side, they're not the code side. But riddle me this. Who writes the code? Who knows what the code should do? And who knows what are the important things in your software systems? Usually, it's not the operations guys, they are the developers. And what developers can do in regards of this, they can instrument their code. They can find the important parts in your system that you can measure, and you can get metrics out of that. And those you can use to set your service levels. Here's a few examples of instrumenting software. So availability, not a very good metric. What is a better metric is like the first one, simplified reliability, kind of refers to that server example, that we have the server and it has downtime sometimes, but not all the time, and then we calculate the time it's running and then time it's not running, and we get a reliability percent, and that's our SLO. It's not very good, because in the example, you might have times that your software is needed and it's not available. It doesn't really matter if the server is running. So what we are trying, we'd rather have is a user-centric availability. So we measure all the interactions. Let's say the HTTP queries are kind of good example, because that's how people operate web applications. And we take all the queries we have in the system and then compare them to the ones that return the faulty response. And based on that ratio, we can get a proper reliability or availability metric and a percentage. So this is kind of the, how much time have I used? Half an hour, okay. Going to get through the last part, but now we're kind of in the middle of this. Now we know what are the kind of the principles of setting up service level for your software project, for your software company and software organization. And a few things to keep in mind is that you're going to build stuff bottom up. You can't set your SLAs or SLOs unless you know what you are measuring and what is the data you get. But of course, to set those metrics, you have to know what your users expect, what they value, what is important to them. Focus is important because you'd rather have few good metrics than lots of not very important ones. So as a rule of thumb, you like to have, let's say, 1 or 2, 3 maybe, which are the most important ones. And of course, if anyone has ever dipped their toes to system theory, you realize that there is only one bottleneck in a system at all times. So you usually it might relate to that. And when you're setting your objectives and agreements, you should always bear in mind that 100% is not feasible. Things break, and this is something that you should prepare for. And it also kind of, if you're aiming for 100% SLO at some point, it will hinder you down, because then you can't make any changes, because any change you're going to make might introduce a defect to your system that's going to compromise that SLO. Also, don't overachieve was a nice one. I think this was an example from Google. They had some system that, from user's perspective, always worked. Like they were promising like 99.59s availability, but usually it ran non-stop throughout the year. So people started building systems around that based on the assumption that it will always run. And then one time it didn't. Everyone was at their throats because like this is supposed to be infallible. So what they did was actually start to schedule downtimes for that reason, that people learn that it is not always available. Also, like, don't aim for perfection. You might have that. This is the thing that our users care about, and then at some point you realize that I was actually wrong, or their tastes have changed. They're using the system in a way I didn't expect. So super good enough is good enough. And nothing is static is kind of piggybacks on that. You might have, when you start with your software, a certain metric might be important for you, but when it evolves, when the demand and the expectations change, so should your service level objectives and perhaps even the indicators as well. So this is kind of a hierarchy of the whole thing. So on top we have SLAs. Your users care about this. SLOs should be internal. You and your developers care about this. And SLIs help you set up the SLOs. But the one I mentioned earlier was the error budget. And what are you going to do with that? So this one is going next. Yeah.
Yeah, what you should do is you should use it like any budget. The agreement works two ways, right? So if there's extra liability, you can experiment.
Good. We are going to get there. So while the user research you might tell you what your features you should build next, this tells you how your system is performing right now. And even like more so like with the idea that if you build it, you run it, the whole operations side and the stability thing becomes kind of an exercise in the software development domain itself. So you just can't just release and forget because now it's somebody else's problem. It's going to be your problem all the time. Hopefully not a problem, but your responsibility at least. So let's go to the error budgets, and we have a way to make decisions on our development process based on data. So, but first, another story time. Like I had a discussion with a colleague from another company, and because this thing interests me a lot, I asked them, like, do they have service level objectives and indicators in place? And they were, yeah, we do. We do. Okay. And how do you how do you produce your software? Well, we have, like any other company, we have two-week sprints, and then we might release software, and then we might have a cool-down sprint. What is a cool-down sprint? I asked them, and they told me, well, it's kind of a session where we don't take on any feature work, but we refactor stuff and ensure the stability and so on. I was like, yeah, that's fantastic. Everyone should do that because, like, then your technical debt doesn't pile up, and you kind of take care of the system while it's running. And so, well, there are a few things that kind of rustle my jimmies, as they say. So I asked them, like, well, you have SLOs. what are you going to do when they break? And they were like, well, we're going to do better next time. And that doesn't really, it doesn't work like that. There should be some action to be taken if the SLO is broken. Action could be like, well, we have a session and look at why this thing broke, and then take it on the agenda. But it's not just like, well, it would be nice to have this SLO, but sometimes we make it and sometimes we don't. Like, if you're going to have SLOs that you don't act upon, then it's time to change the SLOs. And I also had even though I think the cooldown sprint is a pretty cool concept, and other companies should do that as well, the question is it needed? When do you know that you want to do a cooldown sprint? And they said, well, and it feels like it. When we feel like there is a depth accumulating in the system, and we have done a release, and we want to avoid ourselves. And I told them that there's a better way to do this. So, enter error budgets. To use error budgets, we need to have SLOs, and then we have a metric related to that. We'll talk about availability because it's an easy concept to grasp, but it could be the correctness, it could be the HTTP requests, error count, or latency, or what have you. But anyways, we have set the SLO, and then we have measured our competence in regards of that. And if we go over that, like let's say we say that our system is going to be available 95% of the time, and we are like, yeah, it's 97% of the time. We are doing very well. I kind of get ahead of things, but yeah, we're getting back to this. You have 2% to kind of muck around the system before we have to find out. So when we have the budget, we can use it to do risky things. And inherently, doing any change to a running system is a risky thing to do. This means that when we have budget available, we can do more pushes, and we can add more features and so on before we have to really care about our SLO that we have set to ourselves. So more frequent pushes is the usual case of using the error budget. Or we could, let's say, if we deploy stuff and we do some like canary deployment, we could just have a bigger canary groups and deploy faster to more users, because we can afford that. Like, we are not close to breaking our SLOs. And then there is this one that I myself question a little bit, but I've seen it mentioned that you could release a little bit untested code because you can afford that. Don't take it from me. But it is a risky thing to do. Yeah. So going fast to the example, let's say that we have set the 97% SLO, so we are doing some top-notch. 95% is not a very good one, even though it feels like it's a big number. And like these numbers are going to be a bit like not too realistic because they are easier to understand that way. So let's do an example. We're doing some top-notch software developments, and we have set an SLO to 95% availability. That means that our system is down only 17 minutes per day. That's fine, right? But actually, we are doing pretty well. We are having our availability is actually 97%. That means that our system is fucked up. Or can I say that? I did. 93.2 minutes per day. And yeah, that's super cool. So that's where we get our error budget. We have 2% error budget because our SLO is 95 and our actual availability is 97. So we can now use that 2%. So we have additional 28 minutes per day to do risky stuff. So what we do is deploy to production on Friday and go on merry ways because, of course, we are so good at this. And turns out when we come back on Monday, our downtime has gone up from 43 minutes to 58 minutes per day. So 96%, which just slashed our budget in half. And for probably any other budget you ever come across, halving it over the weekend is a sign of something sinister going or just a good party. But in this case, what we're going to do is panic, but no, we don't have to. We have a budget. We can use that. So we have spent half of our budget, but it's for us to spend. And we can do more stuff before we have to actually react to that. Though if one feature does this kind of an impact, you might have to want to check it. But technically, we have a budget, we don't have to. So 40 minutes and 24 seconds per day, we can still do stuff, and our users are happy, and SLOs are not being broken. SLAs aren't either. So this is a good way. Like now we're seeing that we are halving the budget, and so maybe now we could do a scheduled downtime. Maybe we want to upgrade the servers. Maybe we want to do that cool down sprint because we are running out of budget if this keeps going on. So, but also like then we can see that if our daily downtime would be over 72 minutes, so it would break our SLOs, then we just have to pull on the brakes. No more features. We're going to fix the stability now because we are not exceeding, we are not meeting or exceeding our expectations. So, in conclusion, I'm nicely on time. So, service levels, everybody's operation levels align their goals is what I've written here, and the medium for that is the error budgets. So our developers care about the stability as well, but it allows them leeway to implement changes and compromise the system. Well, compromise in a sense that changes are risky. But they also allow us to make decisions on the software development process. Are we going to add new features? Are we going to pay back the technical debt? Are we going to look into performance next, and so on? And the final thing, I say this probably in all of the presentations I have, is that delivering software is a customer service job. The software does not exist for itself, it exists for the end user, and this is the focus that should be had when writing and delivering software. My name has been, and is still, Lauri Suomalainen, and if you want to read a little bit more, I added a few links. I'm going to share the slides as well. And yeah, thank you for listening, and thank you for interacting.
Thank you, Lauri. Anybody has any questions, Lauri?
Maybe I have basic. I'm not a developer.
Yep.
I'm not in a DevOps as well. But the future going to the DevOps mode. So you mentioned that in the PPT, SLO to SLI to SLO, and it's being met. Yeah, that. Yeah, it's being. So in order to see that SLI is met, so we have to care about SLO.
SLIs are the metrics and the indicators we choose based on which we choose our SLOs, and based on the SLO we can choose our SLAs.
So the prerequisite for SLI is SLO should be met. Is that right?
Let's say that prerequisite for setting up an SLO is that you have identified and can measure the correct indicator from your system.
Okay. Okay.
Any other questions and comments? Feedback is welcome as well.
You always have a question.
No, I can freestyle it. Thank you, Lauri. You on one of your slide, you summed up that SLOs are not OKRs. Can you expand on what OKRs are? What's the difference between SLOs, OKRs, and KPIs? Or have someone else do it? That would be
Good one. Albert is our OKR guy, and maybe I could change that, but my let's say my experience on OKRs is that this is something that you should aim for, and you probably want to set an OKR that could be unattainable, that you would shoot for the moon, so to speak. But when it comes to SLOs, they should be realistic. They are not like kind of an overt goals that you one day hope to achieve, but they should be something that you can attain, and it should be based on the data you have. You may change them later when let's say that in the example we have achieved 97% availability consistently, so maybe we are confident enough so we can up the SLOs to 96%.
I was thinking about that part where you mentioned spending the error budget and maybe increasing the push frequency.
Yeah.
But do you think that increasing the push frequency is something that decreases reliability? I found that maybe increasing the number of pushes makes it less code changes per push, and that's according to, isn't it the DORA research, that's something that can
that's
increase
a good thought.
Reliability?
We say that changes are risky, and that is true. It doesn't mean that any change is going to take a cut out of the budget. It is quite true that we could have a code change that actually increases our stability, but the deployment process and releasing and modifying the live service is inherently risky. So the thing is that if you're seeing that you're starting to run out of budget now, then you might consider that, well, let's put a little bit on a break on our releases and work on increasing the stability. But that's a good one. Like changes are risky, but they don't mean that it's always going to affect the error budget one way or another.
As far as I understand it also, it's not about splitting bigger deliveries or commits to smaller ones. It's about making more commits compared to non-commits, like adding more features instead of stopping features.
Yeah.
It's more the flavor of the commits that you're making. If it's stability-focused commits versus feature-focused.
Was there a question?
That was not a question, it was a comment.
Yeah, obviously, like if you're over your OKR SLO, or if you are running out of budget, you might see that like we rolled out the feature. And let's say we have set an SLO that this is talking about the windows of like, well, let's say that we have the OKR that our system should be available 95.x amount in a month. So you do the change early in the month in the is kind of an inspection window, and then realize that slowly but surely your downtime is going to run out by the end of the month. So that's when you realize that well, we have to do a change to this. We can roll back to maybe that's another change, but we can also like if we want to increase the stability of the system, we have to do changes to it. So maybe adding a new feature addressing that defect that we introduced earlier is necessary.
Yeah, I was just thinking about that not much has been mentioned about the aggregation period over which these service level agreements are active over, or how long. Okay, so something broke down a day ago, but our service SLA is only goes from day to day. It's hard to build up a budget over that short of a time span, and so maybe the SLA is for a month by month or week by week. But also, if you're counting on a longer time period to say that we're building up a budget of downtime that we can plan in, sounds like a dangerous thing to be able to plan in on random stuff going badly and saying, we had this much downtime last month, we'll plan on having as much downtime next month. It feels kind of capricious.
That's true. Like going to intricacies of monitoring and setting those like aggregation periods and so on is something that we could have another talk about. But like on the high level, that's the concept. But how it's like implemented on the grassroots level, this is another topic.
Yeah, I just want to make a comment on that. I don't think anybody's planning. I mean, there's planned downtime for necessary actions, but I think it's more about risk management. That's what your error budget is about. Like we can take bigger risks here, so you should be taking risk into account whenever you do something like make changes to a live production system. So your error budget is giving you something you can measure, and all of this is giving you something you can measure, something you can set goals for, and then that allows you to make a calculated risk on something.
Exactly.
That's what I think. So it's not about like, oh, we can have this much downtime this month, but rather about, oh, we can actually make all these intended changes. The risk to the system is not holding us back from making the changes that we have a bandwidth for making for this month.
It's also like when we have the operations and the developers in agreement that this is the objective that we aim for, then it should be easily communicated that we are going to make these changes, and no one should should be able to kind of hold it back there. In other way, like if your system gets unstable, then the operations could be like, we are not going to deploy anything unless it's going to fix this problem we have. So instead of going by gut feeling, you have the data to back it up.
I have another comment on that, on risk management. I really like that sort of conceptualization of the problem. I think about it like I'm at a blackjack table and I have a bunch of chips, and I know I'm getting more chips in an hour. And if I only have one left, maybe I don't want to make a big bet, because then I'm going to go bankrupt. Your SLAs is like your total budget. Like you can go this far, but you can never go further. So when you're really close to that, you might not want to push anything into production, no matter how good your CI/CD pipeline is, because what if? Whereas if you have a big budget, you have a lot of chips. Yeah, I can do a small bet. It's not a problem. Even if the worst thing happens, we have some downtime. It's fine. It's within our budget. Does that make sense? It was a comment back to what you were saying about using your budget that way.
Then I have a question maybe for, it's quite a general one on advice for rolling this out to teams that are not doing this at all. So that would be finding out what metrics are important to your users, if that's like response codes being positive, finding a way to measure that, and then making some compromise between what you currently achieve and what your customers expect, or like try to come up with a number that kind of is reasonable in that window. And then for the window in which you measure, I think what would feel intuitive is it to match your development cycle. If you work at a company and you're lucky enough to use SAFe, maybe like have like a PI planning, or like a stretch of PI, and then like, okay, for this one, our budget is running low, so we want to prioritize features that focus on.
Yeah, sprint could be a good period for that if it makes sense. But of course, like for some products, for some teams, it could be something larger. Probably want to have a period that you get a proper amount of data to weed out the black swan phenomena. Does everyone know what that is? Like if there are some values in the data you get that are wildly off, but it might be a one-time thing.
Just one comment on the sprint, and that's that you're right, but there's a comment there because I've seen it that you might then have to work with different SLOs for each team, because it's not certain that all your teams are having the same sprint length or the same sprint starts, which means that you'll have to have different SLOs and track them in different ways if you're going to do that. So it might not be as easy as you think. Devil's in the details.
And it shouldn't be that as rigid as you think, in a sense that, let's say we run to this problem that in the beginning of sprint our system starts to behave badly. Maybe we have to let's scrap the sprint and do something else instead based on the system stability.
Do we have a last question before we take a break? And let's give Lauri a healthy round of applause.